So we're going to go ahead and get started on our next lab, and what we're going to do in this lab is going to be two motors that simultaneously start, meaning you press the start button and two motors turn on. Now, there's a couple different ways of actually doing this lab. I have a specific way I want it to be done, and I want to kind of explain maybe a couple different variations on it and things that we could do, just so we know a little bit more about this stuff, okay? So this is my drawing of our schematic, and I'm going to try to zoom in because I got my writings a little bit smaller. So what we have here is, again, we have our e-stop, but notice our e-stop is killing the whole circuit. So if I press my e-stop, it's going to kill the power everywhere, okay? So that's going to be our first thing that we're going to really need to make sure. A lot of times I just go ahead and tie it in on the e-stop. You could put a distribution block right here if you wanted to. And then it's just a typical motor control for our first rung. Obviously, start button, stop button, the auxiliary is going to latch, and it's going to go around and it's going to keep our motor running. Now, I want you to notice down here, there is another contact. And now this contact here is identical to this one. They're both auxiliary 1, okay? Now, these are two separate contacts inside of our auxiliary. You cannot use the same contact for obvious reasons. You would have power traveling through it at all times, stuff like that. So be very careful, and I'm gonna point it out when I show you my working model, all right? So what's going to happen is this one's going to latch on, and what's going to happen is this auxiliary is going to latch here, it's going to close, turning our motor 2 on. I'm going to go ahead and change that to a number 2. That's sad. And it's going to keep this one on. So it actually, when you press the start button, this one will click on, and then this one clicks on like a half second later. Okay, it's not instant. All right. Now you might be asking, like, why wouldn't it just be put into a parallel rung? Why wouldn't we just do a drop down here and have them set up? Because I know we did a light circuit in our basic electrical that is kind of close to this one, but it was in parallel, right? Well, the problem would be is if this motor turned off, well, the other motor would stay on. So let's say we had a string of conveyor belts, multiple conveyor belts in line, and one of the conveyor belt motors or contactors went bad or something like that. Well, the other conveyor belts would still run. So obviously they would then run up onto that conveyor belt and it would all jam up. So that's why we would want them to be separate and actually contingent upon the first rung, okay? So that's something very important to kind of point out with this lab. There is variations on it, but we need to be using our auxiliary to latch this motor on. So let's go ahead and let's take a look at our actual running lab, and we'll talk a little bit more about that auxiliary contact, and then you guys can get started. All right, guys, so I got my trainer turned on, and I'm just going to show you when I press my start button, both of the contacts are pulling in. Like I said, it's kind of a click, click, like this one comes on and then this one comes on, okay? Notice I had to use my four contact auxiliary because I needed two normally open contacts for that auxiliary, so make sure you're doing that. And again, if I hit the e-stop on this one, it's going to turn off the whole circuit. If I, hit the stop button, it's going to kill the whole circuit. Just a lot of this is really kind of the same thing we've been doing. It's really that second and third rung there that are going to be kind of changing it up. Okay, so go ahead and build this lab, and then go ahead and write me make a video explaining how it works, and go ahead and move on. So good luck.